Good day. My name is Brian Ketter. I'm the Marketing Manager for Research Control Valves. Today, Dan Fellers and I will be covering the new release of RCVcalc. There's a couple things we want to go through before we go into the software itself. This is a software that we've needed to have. We partner with a company called ConVal, which has been doing this for very many years. This partnership has allowed us to go through and really maximize the quality and the features associated with the sizing software, and we expect that you'll be pretty impressed when we're done with this seminar. To get the software, there's a couple things. You can download it at www.badgermeter.com/RCVcalc. Once you download it, it will ask you you'll need a license. To get that license, you have to fill out some information and send it's called RCVcalcLicense.bri to RCVcalc@badgermeter.com. Once we get that file, we load it into a program that we have that creates a license tool, and we'll send that license back to you. Please save that license to your PC, and then it'll ask to actually link that to RCVcalc, and then the software will be good. The software will be good for 1 year, and then we'll get you a new license after that year. There's also some instruction manuals on the website of how to install and what you'll need to install it. That's on the website. That's located above there under download. People that would use this software in the field would be the process engineers, design engineers, planners, plant managers, and consulting firms. Historically, the ConVal software has been a very, very valuable tool for very many people for a very long time. They've been in business for well over 20 years now. Things to talk about when talking to customers. RCVcalc is powered through ConVal. Please check out the website attached there, thefirstgmbh.com. Look for more information on that. This is a pre-sales tool for our sales channels and also for our end users. It comes with an annual license. What's important about the license is that there's only one license per computer. There's no server licenses. So if you have 3 PCs at your facility, you'd have to get 3 licenses. Again, there's no charge. And we generally will connect you to your local rep within your area to make sure that you have the support that you need to make sure you use this properly. There's a couple things that RCVcalc does not do, and this is really important at this stage. RCVcalc does not go through and compensate for temperature when selecting trims and bodies. We need to still use tech briefs for that. The RCVcalc does not go through and identify the complete valve. It does not do any chemical compatibility. It does not tell you preload, but it does tell you the force, which we can go through a little bit today. It does not do pricing, drawings, or literature also. This is a list of some of the end users and A&E firms that currently use ConVal. This is important because RCVcalc is based on the same platform. So as we go forward with this, we have people who've already trusted ConVal in the field, and this is something that we want to go through and use the same. We use the same calculations and the same information that these companies have learned to trust. The goals for the RCVcalc when we created this was we wanted to give our customers a fine-tuned software program for low flow opportunities. This is that. It's a great product for that. It's available to all end users. So we've invested the proper resources to go through and make sure that anyone who wants this program can get this at no additional charge. It's a very, very easy way to do business with us. There are additions that will be coming in the near future, but this is our current offering, so please stay tuned. One of the neat things about this is that we will have upgrades for the software as well as the database to keep you automatically up to date for future opportunities. This product does do super gas, liquid, steam, and supercritical media. It has a fantastic database, graphical interfaces. There's a lot of things to really like about this. One of the main features that we're proud of is that we have a mass import tool. So when you have an application that has a multitude of valves associated with it, we will give you an Excel sheet that you can actually upload that information to, and then we can download that back into RCVcalc. This will allow us to go through and make short work of a very long project. And when there are changes on this project, you can alter the spreadsheet and get really quick submittal data almost immediately. So that's something that we're only going to do in-house right now. To go get this, please contact customer service. Next thing I wanted to identify is that this tool also leverages NIST database identification. So what this does through the National Institute of Standards and Technologies is that if you already have the NIST database on your PC, RCVcalc identifies that and uploads that within the database section of the software. The benefit of this is that it actually goes through and leverages the fluid properties and mixtures based on the thermodynamic equations of those different properties. It gives you more accurate process calculations for high pressures and for low temperature applications. Well, I'd like to hand this over to Dan Fellers. He's going to walk through the software. Here you go, Dan.
Good afternoon, everybody. What you're looking at here is the interface for RCVcalc. What we want to touch base on first is there's 4 main tabs that we use when navigating through ConVal or RCVcalc. The first tab is the medium tab. This is where we select our media and we put in the various application parameters. The second tab is the pipeline tab. This is where you can put in some specific information if your pipeline size deviates from the valve size. The third tab is the control valve tab. This is where we get some information and can select the control valve, play around with swapping out some trim sets, and get some additional information. And then the final tab, which is called Actuator Forces, is where the calculations take place for the closing force on the actuator. Moving back to the medium tab, we're going to walk through starting up a new application for a potential customer. First thing you want to do is put in an identifier into the top field. Typically, your customer will provide you with a tag number to uniquely identify the valve. And then if you're doing multiple revisions, you can keep track of this with a rev number. The next thing we need to do is select the media that the customer has specified is going to be in their application. We're going to keep it simple today, and we're going to go through and choose water. Now, there's 2 ways to get to the media you're looking for. The first is if we begin to type, you can see that as I type WA, it searches the database and comes back, finishes the text for media that's in there. If I hit enter here, it'll come back and it'll choose water. Now, the alternate way to get there is if we click on the 3 dots here to open the media selection menu, the first thing you're going to see is the favorites tab, and what you can see in here is some of the medias that I've used recently, and as you use the program, your favorites list will build up too. So some common stuff that you'll find is usually on your front page, air and water and similar things. If we click onto the second tab, we get to the substances tab. Because I was already on water, it's pre-selected here, but on the bottom box you can see we have a search text down here, and if I type in, again, start to type water, and it filters as you go. You can see that it's got water left, and then it gives you steam also. While we're in here, we can look at the third tab, which is the fluid mixtures tab. This is something we're going to cover at a later date. This is where we can do mixtures of liquids and gases. If your customer had 20% nitrogen, 20% oxygen, 60% hydrogen, we could build that gas mixture. Same thing with liquids. If it was 50% water, 50% methyl alcohol, we could build that media up and run that application. I'm going to go back to the Pure Substances tab, where we can select water again. This database has over 2,000 predefined media in it. And while we're here, we can look. You can search by the name. There's a drop down here. You can also search for the chemical formula, which we can see in the second column here. We can also search for the CAS number. The CAS number is a unique numerical identifier for the chemical. It's kind of like a Social Security number would be to a person. Again, we'll go back through. I'll type in water. You can see it filters for water. We double click on this and it brings water into the medium section. You can see here in this line, this is going to identify the state. This is the ability of the software to determine whether it's solid, liquid, gas, or supercritical. Certainly we're not flowing solids, but if you put water in here below 32 degrees Fahrenheit, it will tell you that it's solid and prevent you from proceeding with the application. In order to do that, it needs to know temperature and pressure. What we have here is the operating data portion. This is where we have the data entry for the parameters typically supplied by your customer. The important thing to note as we scroll down, some of these are a little cryptic. There is a mouse over function where if we hover over here, we can see that this first line that's shown as T1 is operating temperature. If we move down, P1 is pressure upstream of the valve, and so on down the line. Also over here on the right-hand side is a very beneficial help menu. Any of these boxes that you click on, you can see the box will tell you, or the help will tell you what the box is indicating. Any of these boxes that involve calculations, you can see the help file brings out the equation. The equations involved. You can actually click on this ISA data sheet, which is a familiar output format, and you can see that as we type over here in the boxes, it'll begin to fill in the information over there, and we can bounce back and forth between the two. So let's walk through. We'll do a hypothetical again. We're using water. We'll do 75 degrees, nothing outrageous there. 50 psi upstream, 25 psi downstream. What's important to note now is you can see that the state of the media has filled in, which means the software is telling us that it's 75 degrees and 50 psi, that we do have liquid water. Shouldn't be a surprise to anybody. You can also see the information did begin to fill in over here. And anytime you see a piece of information over here and you want to figure out where it's coming from, if you click here, you can see that by clicking on the inlet temperature of 75 degrees, it brings the cursor function back over to that box. Another important feature for the program is the ability to have drop-down menus here for the units of the application. So in here, a couple temperature variables, not a lot to see there, but under pressure, there's just a huge amount of possibilities, and that reflects the various amount of information you can get from your customer and the various amount of units that they can use when supplying the information. If you do feel the need to do any sort of unit conversion outside of here, there is a calculator function up in the corner. You can do basic mathematical calculations, but there's also a handy unit converter. In this case, we're doing temperature. You can select from other things like pressure. So the first unit is bar, and you can see that 1 bar is 0.1 MPa, and if I go in there and I change that to 2, you can see that all the various units change, and it goes all the way down to all of the various pressure units that are in the drop-down menu over here. It is important to note that if you change the parameter in the units box while you have a numerical value in this box, it will calculate the change for you. So we can see that if I change it to Celsius, it did change the temperature to Celsius. As you can see, it changed the units from Fahrenheit to Celsius. I'll just go through and change them back. If you want to change the units on a global scale, if we come up to this arrow, we can do SI units or US units. If we click this, you can see it immediately went to the more familiar European units of Celsius, bar, and cubic meters per hour. And we can bring that right back to the US units typically used here of Fahrenheit, PSI, and GPM. If we look over here, going down the left-hand side, we have the option of entering P1 and P2, or we can enter in the delta P. Saves you from doing a little bit of math if your customer supplies pressure drop versus P2. And you can see that if I put in the pressure drop of 40, it'll automatically come back and calculate the P2 of 10. We'll go back and change that to the original value, and you can see that when I put in 25, it calculates the other 25 for you. We'll go through and we'll put in a flow rate. It's important to note that you have 2 lines here. QM, that's your flow rate by mass, and you can see over here that it has units of weight. And if we're on the QV, those are units of volume, and in this case it defaults to GPM. It will use the density of the media to calculate one from the other, but it's important to know that if you're looking for volumetric units, you need to click down to the volumetric area. We'll leave it at GPM. Go ahead and put in a flow rate of 4 GPM, and you can see that it did come back with a calculated CV value of just shy of 0.8. If we want to add a second operating point, there's two ways to do that. The first way to do that is click second operating point, and all that basically does is open these fields up and make them available to edit. I can go through again. I can put in the same values, 75, 50, 25. Now it jumps down to the volume flow because I've already established we're doing volume flow. And I can come through and put in 2 gallons per minute. You can see again that for that second operating point it calculated a new CV. If your temperature and pressure information from column to column isn't changing, rather than clicking third operating point, you can actually click this little copy icon, and that will drag over all the identical information from column 1, and then again we can add an additional flow rate. All right, coming through after we get our 3 case conditions into the system, we're going to have to begin selection of our control valve. Right in the middle of the top icon bar here, if we click on that, what we're looking at here on the left-hand side is the series of valve we're looking to select from, and on the right-hand side is both the size of the valve. You can see half, 3/4, and 1 inch, and then the associated CV value of that trim, and then the Badger letter designation over here. So we want to get into the regular RCV family, and we're going to come through and we're just going to pick a standard 1/2 inch C trim, which has a CV of 1.25. That's a good fit for our CV of 0.8. What you can see here is we're only seeing C trim 1.25, B trim 2.0, A trim 2.5. The software, because we have these 2 boxes checked here, is applying some constraints and giving you recommendations for the best fit trims. If there's a trim you wanted to see, if we scroll down, you can see it stops at a 1 inch 3.0. If you wanted to see what a 1 inch 6 would look like, you can get there. You just need to deselect these 2 check boxes. And then if we scroll down, you can see that the 1 inch 6.0 is there. If we go all the way back to the top, you can see that the 1/4 inch P trims are there, which certainly, as the software recommended, are not a good fit for this application. I'll put the constraints back on. We're going to grab this C trim. We'll click on it once. And I can't get to my accept button, so we'll give it a double click. And that's actually going to bring in the parameters for that trim. You can see now that the travel line has filled in. What this is telling us, especially if we click on the box, we can go to our help menu. We can see that this box is the travel percent of this trim at 4 GPM for these parameters. It's important to note that if you bring a trim in, you can see that we're at 63%, 31%, and 15%. If you want to try a different trim, there's 2 things you can do. You can click Select Valve again. We could bring in a B equal percentage trim to see what that looks like. We can see that we're at 80%, 65%, and 49%. If you want to compare 2 trims on the same chart, we click on this characteristic button, and what it brings in by default is the trim you had initially selected. So this is the B equal percentage, and we can click this comparison button, and let's just see what an A equal percentage looks like. We'll double click that. Now you can see the blue points represent the A equal percentage. It's a larger CV. It brings the points down the flow curve as we would expect. We can even try a larger trim. Not in the 1/2 inch valve, that maxes out at the A trim, but if the customer wanted to do a 1 inch valve, we could see what the 3.0 equal percentage would look like. Again, it brings the points farther down the curve. If you choose to convert the software over to the comparison trim, you can click Apply, and we can exit, and now you can see that we've moved over to that comparative trim. Let's go back to our original C linear, because we can compare the linear versus equal percentage. We'll take a look at that. So you can play around with the values, bring trims in and out, get a feel for which ones get you equidistant from the top and bottom and is a good fit for your customer. So we basically fully define an application here. We've selected a valve, half-inch with C-trim. We're between 63 and 15% open. That's acceptable. We'll move over to the Pipeline tab. Over on the Pipeline tab, the important thing to notice about the Pipeline tab is that if your line size equals your pipeline size, which this box comes in checked by default, you really don't need to do anything here. The equations here are usually used for flow velocities. As your pipe diameter increases, your flow velocity out of the valve will decrease. If you deselect this, it allows you to edit these fields. So if your pipe upstream of the valve is something other than half-inch, just like on the valve selection area, you can click on here. You can modify your variables. But again, that's not too important unless your line size is different than your pipe size, or you're using some very heavy-walled pipe or something that changes and deviates from what you would standardly see as a standard. If we move to the Control Valve tab, we can go through here. It tells us, based on what we selected, we're in the RCV family. There's that half-inch 1.25 C linear trim that we picked. And it does start the traditional RCV model code for you, 1002 for half-inch, and it does bring in that C linear trim. Because in the program here, we're not selecting a body type, we're not selecting materials, we're not selecting trim materials, and those would be what these other X's are for. We can't make those decisions to fill out the model code at this time. We can walk down. It's a straight globe valve that was selected, parabolic plug, flow to open. These things are all standard for the Badger valve family. The basic characteristic is linear. We selected that when we grabbed the trim. This is the calculated flow coefficient. The CV100 is our selected CV. Again, that goes back to the C trim that we picked. And it does go through and give you a suggested flow coefficient of 1.1. And we actually picked the next largest trim up from there. Down at the bottom again, there's a summary of the travel for the valve. Again, if you mouse over on the left-hand side, it gives you more info. This is the flow velocity exiting the valve, and this is the sound level, the predicted sound level in decibels. If we bounce over to the Actuator Forces tab, and we go through, it did carry over the maximum upstream pressure from the medium tab of 50 psi. It actually brought in the second downstream pressure. And what it's walking through down here is some various force calculations. What's important is the bottom one, required actuator force. This is not preload. Brian touched on that during the PowerPoint. This is actual linear pound force. And what you need to do is divide that by the surface area of the diaphragm to get the PSI. So with our half-inch valve with 11.3 square-inch diaphragm, you're looking at just under 2 pounds of preload, which is certainly important to note for shut-off purposes for your customer. Now that we've basically configured a whole valve, ran through a whole application, selected a trim, let's see what we can do for outputs. We talked about this briefly before. Over here on the right-hand side, there's this overview document. There's the IEC, which is the European format document. Then we have the ISA data sheet. Again, if you need to see where any of this information is coming from, if we touch on this density here, you can see that that density information is coming from that box. If we touch on vapor pressure, you can see that that information is coming from that box. It's also important to note each one of these menus has a plus sign. That plus sign is an expansion button for the information that's contained here. What you see by default is the more common, readily used information. Behind the scenes, if we click on this, you can see there is more information. Certainly down here at the fluid operating data, if we click on that, you can see that there is information on calculated viscosity, vapor pressure, vapor temperature, sound velocity, which again has to do with noise levels. It actually calculates input, the density of the media into the valve and density out of the valve. That's a more important factor for gas phase media. You can see it does change slightly here, but for liquids that's usually inconsequential. But if we look at our available outputs for the application, if we go over here again to the top menu button and click on the spec sheet, what it's going to do is it's going to take a second, it's going to generate 2 Excel files. Now the first Excel file is a ISA data sheet that is filled out with all the information that's been supplied to the program up to this point. Parameter data is at the top, followed by the lower portion of the sheet, which is typically used to define the rest of the valve. It did bring in the straight globe valve. It brought in your line size, the flow to open, the packing material. It's a parabolic plug with a linear profile. You can use this sheet then to continue on and define a positioner for the customer, define the actuator information, any switches, air sets, tests, or special considerations you need to do. If we move over to the other output sheet, if you've gotten anything from us that's been sized internally, you may be familiar with this format. It did come through, and it brings the information who created the file. This is our header information that we put in to name the valve. It did carry that rev number over, and then the valve tag information came with too. Again, a brief summary of the valve we selected: straight globe valve, linear. There's that C 1.25 trim set again. And then there's a nice little summary chart of, again, the process data. Here's your travel information and your calculated CVs. And if we scroll down, then we have this output graph that you can supply to your customer. There is one other output that you may run into that we'd like to show you. If you do run over to, just like anybody else would, you typically click on File and Print. You're going to get this prompt box. Let's just run through it. We won't make any alterations. I'll just hit OK. And I'll do it to PDF so we can see what the output looks like. And what you get out of here is, again, it brought in the header name. We've gotten feedback from outside personnel that this is not the most intuitive format. It really is more of a raw data dump. It's everything under the sun. We did go through and have the ISA data sheet and the standard valve output created to make it a little more intuitive for your customer. But my guess is anybody familiar with Windows-based programming is they're going to click File, they're going to click Print, and if you end up here, that's why. We highly recommend, rather than File, Print, you do click on the spec sheet. All right, one other thing we did want to show you here, we still got our water application up on a 25 PSI drop. What's important to note here is you can see that the calculation is non-critical. If we go through and I increase this P1 up to about 200 PSI, you can see that the non-critical suddenly becomes incipient cavitation. What that means is we're right on the cusp, we're on that borderline of cavitation where the bubbles begin to form. If we continue to increase P1, you can see that it crosses over into severe cavitation. And this is where, when the cavitation warnings pop up, you want to start thinking about the harder trim materials and taking some preventative measures on that part. The other thing we can do is if we continue to bump up the temperature, you can see because the vapor pressure has come up with the increase in temperature, now we have choking cavitation. And what that means is the bubble formation is so vigorous that it actually starts to inhibit the flow through the valve. Again, it's not to say that the valve can't do this flow. We can still see that with the C-trim, the valve would be 20% open. It's just giving you that warning to let you know that your flow through the valve is becoming more and more damaging. If we keep bringing the temperature up, you can see that we've now crossed over into flashing. Basically what that means is we're entering the valve as a liquid and we are leaving the valve as a gas. Again, it's not to say that that's a problem, it's just making you aware. You can still see that the C-trim is working. We'd be 26% open. You can continue on. So you can see here that it's still telling you the state is liquid, which makes sense, because at this pressure, the 250 psi, we're at liquid, but then water at 350 degrees and 25 psi is flashing to gas. One other thing we did want to show you, let me return this back to our parameters we started with. I can come up here, and we did want to show you that for our low flow applications, when you click on select a valve, I'm going to relieve the constraints again because a P-trim isn't applicable to the parameters we've put in. You can see here that we've lumped P10 through P18 together. The reason we did that is that we would like to take a look at those. If you run into any CV calculations that direct you to the P10 through the P18 trims, please get in touch with the factory. We're going through processes now to better serve you on these ultra low flow areas, but we would like to at least have a touch on that, if you would. And speaking of communicating with the factory, if I close out of here, what's very important to note is this factory check button. If you click factory check, it's going to ask you if you'd like to attach the current calculation to a support email. If you say yes, it will go into your local email tool. And what it's going to do is it's going to generate an email. And what you can see here is it actually created a CCV file, which is the ConVal extension. It's attaching that to an email. And in this box up here, because I'm at the factory, I have the ConVal support email in here. But what's going to come up when you click on this is the designated support representative that was programmed into your ConVal license. So if you're an end user, the support email is going to be generated to your local sales representative. If you happen to be one of Badger's sales representatives, the email is going to default to the factory, and then that can be passed on to us to take a second look at. If you're going to do a second application, you can have multiple ones open at the same time. Certainly, if we go over here, navigate over to a new application, it'll bring up a fresh window. We're going to run through one simple blended gas application because that's probably the first blended application that you're going to run into. We're going to name it, we'll name it test gas, blended gas, Rev 1. So we're going to go through, and I'm going to click on my button over here to bring up my media database, and I'm going to click on fluid mixtures. We touched on this tab a little bit. And what I'm going to do is click on gas mixture. And if I go to substance composition, I can click on this again, and it's going to bring up some gases that come stock and some gases that have been created before. But what's important here is to click on this new button, and we're going to name our gas. It's good to put an intuitive name to it, so we'll call it 50 oxygen, 50 nitrogen. And we're going to come down here and build our gas composition, and I'll click Add. And it's going to bring up the database menu. I'm going to click on Pure Substances, go down to my search function, type in oxygen. It's going to bring up oxygen. I can pick it, carry it over. It's going to ask me what the mole percentage is. I'll click 50. Now it's asking me for another substance. I can go down to the pure substances again, search again, type in nitrogen, click on nitrogen, carry it over. It's going to balance it out for me at this point. I'm going to stop. We're going to keep it a two-gas mixture, 50-50 blend. I click OK. What you can see now is in my data table here, I have this 50-50 nitrogen-oxygen blend. That'll stay there unless you delete it. I'm going to click, make sure that's highlighted and carry that over. You can see that my 50-50 nitrogen-oxygen blend is there. And we're going to process this just like we did before. 75 degrees, 200 psi, 100 psi downstream. It calculates delta P for us. We're going to go to volumetric units again. The program is intuitive enough to know that most people don't measure gas flow in gallons per minute, so it did go ahead and change your units to gas phase flow of standard cubic feet per hour is the default. You can go through, you can see it's got liters per hour, liters per second, cubic meters per hour. We'll keep it simple, standard cubic feet per hour, or we can even do standard cubic feet per minute. We type in 10. It does again use the density to calculate a mass flow rate. We could put in a mass flow rate if that's required, if your customer is using a mass flow sensor and measuring their stuff that way. Again, we have the expanded menu down here. We can look at some of the parameters. Again, the mouse rollover is helpful here. So this is the real gas factor. This is how much the gas deviates away from 1, which is an ideal gas. You got your heat capacity ratio, and again, your sound velocity, vapor temperature, vapor pressure, and density. And once again, we can go through and grab some other operating points. 8 standard cubic feet per minute, 5 standard cubic feet per minute. Our CV is about 0.09. We'll go up and we'll grab a valve. And it puts us on the half-inch 0.13 linear. We want to make sure we're in the RCV family. It will default to the top of the list. If you want the RCV, you do have to click there. We'll bring in that 1/4 inch H trim. You can see that we're 71% open, 56% open, and 34% open, which would be perfectly acceptable in these applications. The flow is non-critical. All right, so what you can see here is we do have that H trim pulled in. Again, if we wanted to modify that trim to be a different characteristic, we can click on this button, click on comparison, RCV. We could bump it up to see what the F equal percentage would look like. Double click that. It will bring in that equal percentage curve. And if you wanted to transfer over to that trim, you would click Apply and click OK. And then you can see here we've carried that other trim over. And once again, if you have any trouble getting results you're happy with, or you have any questions, the best thing you can do before you call, and we'd be happy to take your call, but if you hit factory check, it will come over and generate a file that contains all the data for the process you're working on. And if you can shoot that over to us, we can open it up and we can see exactly what you're seeing without you having to, re-describe your entire application to us over the phone. So certainly use that, take advantage of it, and we'll be happy to get you up and running. All right, some additional topics as we close out here that we wanted to touch base on. Certainly we showed you the media database. As we said before, there's over 2,000 predefined media in there. You can mix them, match them, blend them, play around. What you're going to find, though, is you will find an application where the customer says, this is my proprietary mixture, and I can't really tell you what it is, but its densities 1.1 grams per cubic centimeter, and the viscosity is 5 centipoise, and the vapor pressure is minus 14 psi. And we have the ability to support that. We can go through and enter that data manually, and as long as you have the appropriate parameters to define the media, you certainly don't need to pick one from the database, and you can work directly off the parameters from your customer. There is some customized graphics tools in here we'd like to show you. Any of these places where there's a calculator, you can define a graph that involves this parameter, so in this case CV, and you can graph that against a different parameter. So if I come through here and I want to graph the CV versus pressure difference, so that's valuable. What does my CV do as my delta P changes? Because I clicked on the calculator for CV, that's my one variable, and I want to compare it to pressure difference, and I click update. It'll take a minute. It's running some calcs behind the scene, but it'll come back with a nice graphical representation of what the CV does as delta P increases. And what you can see here is what you'd expect. Your y-axis is the flow coefficient, and your x-axis is the pressure difference delta P. And with all flow applications, you can see as delta P increases, the required flow coefficient decreases. If I X out of here, it's going to ask me if I want to save it. If I say yes, over here on the right-hand side is a new tab that has some graphs in it, which we can retrieve again. We actually have to update it again. But if you find a graphical parameter that you like or that you think your customer would find valuable, you can save it and bring it up again. The other thing we'd like to touch on briefly, we're not going to do any calculations on this today. What we did today was we solved for CV, or the flow coefficient required for the valve to meet the flow requirements of the process. If we use this drop-down, there are some other variables we can solve for. So there's 4 variables in here. You can solve for any missing one if you have the other 3. If you have the CV of the valve in P1 and P2, you can solve for the mass flow. If you have P1, the flow rate, and the CV of the valve, you can then calculate the pressure drop that's required. You can also manipulate, we'll show you a quick one here. So this is, we'll solve for flow again. And if we go to, and we can change our travel, we can go through and say, hey, what's the max flow at 100% travel? And if you watch, we are at 10 SCFM here. And if I change that to 100% open, we're now at 33.9. So based on these parameters, we can see that the maximum flow through this valve at this pressure drop and this temperature would be just shy of 44 SCFM. All right, thank you everybody for being with us today. Before I hand it over to Brian, I would like to just reiterate the factory check button and the value that has. If you get stuck or you have any questions, use the factory check button. It's a great way to get in touch with us. It includes all the information we need to help you out. There's a lot of stuff here. This is certainly new to you. We've been using the program internally for a couple of years now, and some of our counterparts at our division in Europe have been using it for over 10 years. So we've got quite a bit of experience. We've got a direct line to the to ConVal if we get stuck, and we're certainly here to help. I'm going to turn it over to Brian and let him close it out.
I'd just like to say thank you. This is a long time in coming. We're very excited about this new software. We believe it's going to help our customers and our reps sell more product for us, and we believe it's a very, very valuable tool to help you solve your problems in real-life applications. Please feel free to contact us at any time if you have any questions, and we thank you for your business and the opportunity to help you. Thank you. Have a good day. Bye-bye.